Hello everyone, this is Hemant from Intellipaat and I welcome you all to this session on Docker tutorial for beginners. Today in this session we are going to learn Docker from scratch. Yes, you heard that right. So if you're one of those who have heard Docker as a buzzword and want to learn more about Docker, you have come to the right place. So without wasting any more time, let's go ahead and start with the agenda to see what all we'll be covering in today's session. So we'll start this session by an introduction to Docker where I'll make you understand why do we need Docker and what Docker is exactly. Once you have understood that, we'll look at some of the common Docker operations that you will be performing in your day-to-day life. Once we're done with that, we'll go ahead and understand what is a Dockerfile, followed by what are Docker volumes. After that, I'll show you guys how you can break a monolithic application into microservices using Docker. Once we're done with that, we'll move on and learn what is Docker Compose. Then we'll learn what is container orchestration. And towards the end, we'll deploy a multi-tier application on the Docker Swarm, which is a container orchestration tool by Docker. All right. So guys, this is our agenda for today. I hope it's clear to you. So let's go ahead and start with the first topic of today's session, which is why do we need Docker? So, guys, Docker was essentially a need which came out of the problem that we're going to discuss just now. So, imagine yourself as a developer and probably you're just creating a website on, say, PHP, right? So, if you create a website on PHP, the first thing that you would do is write some code. Now, when you want to test that code, the kind of environment that you would be putting it in, let's see what all components would be there in that particular environment. So the first thing that you would need in this environment that is around the PHP file is an operating system, right? So an operating system which probably would have a browser or would have a text editor, right? So you need an operating system to work on. Now, secondly, because you are developing a PHP application, of course, you need the PHP software installed on that operating system so that your file can actually work. Right now, when you're developing a web application on a particular language, it's not just the language which will suffice with what you're doing. You also have to take into mind the third party applications, the third party libraries that you would be including in your code, right? So, the third component that you would need when you're developing a website are libraries, right? For example, if your PHP website has to connect to a MySQL host, then it would need a PHP MySQL library for connecting to it, right? So these are the components that are basically required by a developer to run his program, right? So what he does is he writes a program, he configures the environment according to the program, and when everything goes fine, his program works well. Now, the problem occurred when this particular program had to be given to someone else, right? So the developer finished his job. Now it was the job of the tester to check this program. So the developer would give the PHP file to the operations guy, and let's see what the operations guy would do. Now the operations guy in the same exact position that the developer was when he was starting to develop his code. Right. So, but the difference over here is now the PHP file is running. It is just that he has to run this file on the system, on his system, right? So the first thing that the ops guy would do is replicate the environment that the developer is having, right? So he would get the same OS, the same software, and the same libraries to run that PHP program. Now, there are a lot of versions for a particular software. For example, for PHP, you have PHP 7, which is currently running, but there are companies which are still, they're still working on PHP 5.6 because of, probably legacy problems or because the commands have changed. And if they want to move on to 7, they'll have to change all the commands in the code base. Etc. There are a lot of reasons, right? So there is a particular version that this company is also following, right? So this ops guy has to have the exact same version so as to make the file work of the developer, right? Now he tried his best possible judgment in it and he installed the PHP software. He installed the libraries, he installed the OS, but still the problem was the ops guy couldn't make the file run. And he came to a conclusion that the code is faulty. But the developer says it ran fine on my system. It's your system which has the problem, so fix it by yourself. So these were some of the statements which were exchanged between developers and operations guy. I mean, if you think about it, it was actually nobody's fault, right? The operations guy did what he could in the best of his ability to replicate the environment, but it didn't work out. Now, you guys might argue that why don't we, use VMs in this case? Probably the developer could work in a particular VM and then just give that VM to the ops guy, and then he can work on the same VM and probably run the file, right? I mean, that is a viable solution. But the problem is the size of VMs is too large to give to the ops guy and give to the testing guy on every feature that a developer adds, right? For in that case, every developer has to have a VM that he's working on, has to have his own version of the VM, because if you are adding, say, feature A, and feature A requires 3 or 4 more libraries that you have included into your particular VM, it'll become inconsistent with what other developers have. Now imagine the ops guy having several versions of VMs and he not knowing what kind of VM he has to impose on the production server or on the testing server, which basically will act as the final version of the image on which all the features of all the developers will work. Now it's a very hectic situation. So the problem was that VMs were very large and they were complex as well to handle when we are talking about staging area or the deployment area, the production area. They were a little difficult to handle. Now, this was the problem that was there before Docker. So, what did we need? We basically needed a wrapper. Like in the case of what we just discussed, the wrapper was a VM wherein it basically contained all the operating system files, all the software, all the code, and all the libraries together, and could be basically lifted and shifted to a different system where it would execute, right? But we needed something more portable, we needed something more smaller that could easily be given to some other person for testing, right? We needed something like that. We needed a wrapper around our files. And the answer to this was this particular scenario, that now if we get a wrapper which will basically contain all the files, in that case each and every environment of ours will become the same. The developer environment is going to be the same, and the moment it gets passed on to the ops guy, he will again deploy the same wrapper, and his problem is also solved because the ops guy does not have to match the versions of the OS, the software, the libraries, because everything is there inside that wrapper, or everything is there inside that container, right? He just has to run that container and he can just see if the code is working properly according to what has been specified or not, right? So the answer was that all the environments, the developer environment, the staging or testing environment, the production environment, all of these environments are now going to be the same, right? And this was possible using Docker. So what is Docker? Docker is basically a software which helps us creating this wrapper around the files of a code, the operating system, and the libraries that we mentioned that are required for a particular code to work, right? But the awesome thing about Docker is that you do not need the environment to be in GBs, right? You do not need it to be somewhere around 900 MB or 800 MB or 1 GB or 1.5 GB. A container could be as low as 50 MB. That is the size of a container called Alpine. It's as low as 50 MB. So it becomes very easy to basically give it to other people to test your code with all the environment set up in that particular container, right? So Docker is a software which helps us enable that. Docker is basically a tool which helps us in containerizing an application, right? And now let's see how basically Docker is doing this. How is it so portable? How is it so low in size? So basically this is the architecture of Docker. So at the base level you have the hardware. That basically means that you'd have a computer, and on that computer you would have an operating system present, right? So this is your operating system. So it's as simple as you have a laptop, and on that laptop you have Windows or Linux installed, right? Now once you have the operating system installed, the next thing is the container engine that you would install. So the container engine is nothing but the Docker software that you would install on top of your operating system, and that is it. Once you've installed the container engine, you can run any type of container that is there in the repository on the or on the web which is available. For example, if your code needs an Ubuntu container, right, all you have to do is write Docker run Ubuntu. And what would it do? It would basically download the Ubuntu container, and then you can add your code files inside that Ubuntu container and start working, right? But how is it low in size? How is it not in GBs when we compare it to the Ubuntu operating system? It's around 800 or 900 MB, right? The Ubuntu desktop version. But how come this container is so small? So the answer for that is the container does not contain all the operating system files, right? So as you can see, the container engine actually shares its space with the operating system. So a container is void, or a container does not have a kernel in place, right? It shares the underlying kernel of the operating system on which the container engine is installed. So if I talk about, say, you have an Ubuntu operating system or you have a Windows operating system, and basically what you do is you download the container for CentOS. So CentOS is basically a Linux distribution, right? So you download the container for CentOS, and now when you're working in that container, you feel as if you're in CentOS. But the point is that the CentOS operating system is actually not installed. What is basically happening is your container is sharing the resources from the operating system, but your container has the minimum binaries and libraries that are required to run the CentOS commands, right? For example, for installing anything on CentOS, you pass the command yum install and then the package name, right? So it would have the yum package in there in the container, right? It would have all the repository URLs there in the container, and that's how it behaves like a CentOS operating system, although the container is nothing but a set of binaries and libraries which are important for the CentOS commands to work, right? That is all what a container is. But with the underlying virtualization of the kernel or the BIOS of the operating system, your container seems to be like an operating system, although it is not. And because of this very reason, that it virtualizes the underlying kernel or BIOS to make it as if it's running on its own, that is it is its own kernel or BIOS, is the reason that the containers are very lightweight, because they don't need to have all the files required for an operating system. They just need the bare minimum binaries or libraries required for that particular environment to work. Okay. So if you again come back to see this architecture, you have the hardware. On top of the hardware, you have the operating system. On top of operating system, you install the Docker software. And on top of Docker software, you run containers. So all these containers have the minimum binaries or libraries. And on these, you basically just put your code. In my case, I will put my PHP code on top of the container, and that would be app1. And there could be multiple containers running on my system. For example, one code file is running in Ubuntu, the other code file could be running in CentOS container, the third could be running in some other operating system or some other flavor of Linux container, and all this is possible using the Docker software. Okay. So this is the architecture for a Docker container or a container in general. And now let us compare it with a VM, right? So I gave you the example of VM when I said that VMs are heavy in nature. So let us understand how containers are different from VMs. All right, so on the right side, you can see the architecture of VM, guys. So on the VMs, you have the hardware, which is the same as the Docker architecture that we saw. Then on top of hardware, you have the host operating system, which is the same as the Docker container that we saw. Now, on top of the host operating system, you have a hypervisor or a VirtualBox kind of software, which will basically virtualize the hardware from the operating system and give it to the VMs running on top of it, right? So you have a hypervisor software in case of VM architecture, and then you have the container engine software in case of a Docker architecture. Then on top of the hypervisor, you have the guest operating system. And this is where the all of the difference is, right? So in case of containers, you just have the bare minimum binaries or libraries which are present. But in case of your VMs, you have the whole operating system, which is basically installed on top of the hypervisor. Right. So because you have the whole of the operating system installed, your size of the VM is quite bigger than what you have in the container, right? Now, you again, the VMs could be multiple in nature. When we talk about how many VMs can we run on a machine, it totally depends on the specs of the machine, right? What are the specifications of the machine? So in VMs also, you can run multiple VMs on a single machine. And also, one thing to notice over here is that there could be or there could not be a host operating system in case of VMs, right? So, in case of virtualization technologies, it has advanced this much that the hypervisor itself, it does not require a host operating system. It could directly work on the hardware level as well. But usually, when we guys work in R&D, or when we have the kind of laptops that we have, right, the kind of specification that we go ahead with this kind of an architecture where we have an existing operating system. On top of that, we install tools like VMware or VirtualBox, and on top of that, we install the VMs. All right. So guys, this was the basic difference between a Docker architecture and a virtual machine architecture. Moving forward, now let's just discuss. So we have understood why do we need Docker, and we have understood that what Docker is exactly. Right now, let's go ahead and see how we can install Docker on our machines. Now, when it comes to installation, there could be basically three kind of installations that you might come across. You could either have an Apple or a Mac system that you're working on. You could have a Windows system that you're working on, and you could have a Linux distribution that you're working on. So let me walk you through all the three domains in basically installation, so that we are on the same page once we come out of installations and when we are doing hands-on. I hope you guys all will be able to, go along with the video as we are performing the hands-on. All right. So if you're on Mac, guys, all you have to do is go to this link. So this link is basically going to download the Docker toolbox for Mac. And once you have the Docker toolbox, it'll basically install everything. It'll install Compose. It'll install the Docker software. It'll install the other components of Docker. So you don't have to worry about what component is what. But basically, just go to this particular link, download the Docker software. And once you have the Docker software, just come back to this CLI and this just pass the command Docker version. And if you get the reply as the version of the Docker which is running on your system, it's your software is basically successfully installed, right? So this is the installation for Mac. If you talk about the installation on Windows, just go to this link, download the Docker toolbox, and everything is going to be set up automatically for you, right? When we talk about Ubuntu, things are a little simple on the Ubuntu side. All you have to do is pass these commands and your Docker would be up and ready, right? So for our sake, we will be basically doing all our hands-on today on the Ubuntu distribution of Linux. So what I'm going to do is I'm going to just go back to my terminal so that we can use the PuTTY software to basically connect to our Ubuntu distribution. So just give me 1 second. Alright guys, so this is basically my Ubuntu distribution, right? So what I'm gonna do is I'm gonna install Docker in it. So the first thing that I would pass is the command sudo apt get update. So the first command that I'm gonna pass is sudo apt get update. Once I've done that, the next command that I'm gonna pass is sudo apt get install docker.io. All right, and then you'll be prompted for a yes or no. Just type in Y, which will mean yes, and this will install all the packages required for Docker to work on this particular system. right? So if your internet is fast, it will hardly take a minute to install Docker. And once Docker is all installed and set up, we can go ahead and check whether Docker is working on our system or not by typing in sudo docker version. So just give it a minute and this will all be over soon. Alright, so Docker is installed now, and all we have to do now is check the version. So it's Docker hyphen hyphen version. And as you can see that the Docker version is 18.061 CE and the build is this. So this basically confirms that Docker has been installed on our system. So I've successfully installed Docker. So now let's go ahead and see what is in store for us on our next slide. Alright. So we have installed Docker on our system, guys, and I hope you guys have also, if depending on the kind of OS that you're working on, I hope you guys have also installed Docker on your system. If not, you can pause this video, do that first, and come back because I would want you guys to learn as much as you can from this session, and I would want you to follow me while I'm doing the hands-on so that you get the maximum knowledge possible from this session. Alright, so the next thing that we're going to do in this session is get acquainted with the Docker container lifecycle. Alright, so basically this is how this is the whole lifecycle of what a container goes through when we talk about the Docker ecosystem. Now, if you guys know what GitHub is, or if you guys have worked on GitHub, you guys might know that there is a central repository. Whenever you start or whenever you have to start working on a particular code base, the first thing that you have to do is pull the code base from the central repository. Right, so that central repository is nothing but something on the cloud or something on the internet which holds all the code base for your organization or for your team that everyone is working on, right? So that is basically a central place where you can download everything from. And similarly, in Docker, we have something called as Docker Hub. Now, Docker Hub would contain all the container images that are present, that are open source images that are present. For example, I told you that you could run a container on Ubuntu, you could run a container on CentOS, you can run a container on Alpine, you can run a container on some other operating system. So all of that is present on Docker Hub. Right, so the first thing that you do is pull an image from Docker Hub onto your system, and this is your system where Docker engine is installed. And basically what you download from Docker Hub is an image of a container. Okay, so you get the image, and the next step that you do is you run that image, and the moment you run an image, it becomes a container. Right, so you can run that image, and that would basically be the normal way or the normal state of a container that it is running. Once you want to stop a container, that is again a life cycle state that when you're done with working on the container, you can stop it. And once you are done with everything, you don't need it on your system anymore, you can remove it. So this is the life cycle of a container. The first thing that you do is you pull it from Docker Hub, it becomes an image, then you run that image, and it becomes a container. And the containers can either be in a running state, in the stop state, or in the deleted state. So this is the life cycle of, this is basically, I would say, a summary of what happens inside Docker. But of course, there is more to it, and we'll see as we move along in the session. Okay, so we've understood the common, the common ecosystem of Docker. We've understood what Docker is. We have understood how the containers work inside the Docker ecosystem. You first download them, they become an image, then you run that image, and then they become containers, right? So with this knowledge now and with Docker installed on our systems, let's go ahead and perform some common Docker operations that you would be doing when you are working on Docker in your day-to-day life. All right. So this is the first command that we can try out when we are working on Docker. All right. So whenever you want to find out what version of Docker that you're working on, you can simply pass this command Docker version, and then you can basically get the version that you're getting on. Let me quickly change the color of the terminal because I feel that this color is a little dull. So that it becomes better for us to see. Just give me 1 second. All right, much better. So when we pass this command docker version, you get the docker version, the current docker version that installed on your system along with the build name. And this is exactly what this command does. All right. The second command that you can go ahead and try is docker pull. So we saw the container lifecycle. The first thing that you do is pull the image from Docker Hub. All right. So what and the syntax for pulling the image is docker pull and then the image name. So as you can see in the screenshot, we passed the command docker pull ubuntu, and what it did was it downloaded a container from Docker Hub automatically. So what we can do is we can also try that out. So let me just clear the screen. All right. Okay. So we'll type in docker pull and then the image name. So this is the image name and we'll hit enter. All right. So sorry about that. I forgot to use sudo. All right. So sudo docker pull ubuntu, hit enter, and this would download the latest Ubuntu image on your system. Now remember guys, we have just downloaded the image. We have not run the container yet, right? So our next command would be docker images. So now if you want to check what image did you download and is it existing on your system to verify, all you have to do is type in docker space images. So about that. So sudo docker images, and then you would be able to see the image that you just downloaded. Okay, so this is the image that we just downloaded, and you can see the size. It's 86.2 MB. 86.2, that's too low to be an operating system, right? Imagine the beauty, guys. So an Ubuntu operating system, a VM that you're working on, is I think around 1.5 or 2 GB. But when we talk about this container, it's hardly 86.2 MB. Awesome, right? So once you have seen the images, the next step would be to run this image, right? Now to run this image, the command is called docker run and along with the image name, right? So you use some flags as well when you're using docker run. So let me explain you while I'm executing this command. So sudo docker run, this is the syntax. The next flag that you add is hyphen IT, which basically means make the terminal interactive. Hyphen D, which means run the container as a daemon. Run the container in the background. So whenever I run the container, make it running in the background till basically I stop the container. So that is what hyphen D does, right? So the command would be sudo docker hyphen IT. IT means make the container interactive in the terminal so that I can also pass in commands. Hyphen D, which basically means make the container a daemon that it should be running in the background even though I'm not working on it. And then you pass in the image name. So the image name is Ubuntu, and then you hit enter. So can you see you just got an ID of the container? So basically this, if you get something like this, this means that your container has just started. And then to view all the running containers, all you have to do is pass the command docker ps, and that would list down all the containers which are currently running in your system. So let us do that as well. So let me just clear the screen. So just pass in sudo docker ps, and this would basically show you the container which you have just started. So as you can see, I started the Ubuntu container 29 seconds ago, and this is the container ID for that particular container. All right, so my container is running. So what's next? Next step would be to see Docker PS would basically show you the containers which are in the running state. But what if you want to see all the containers which are there in your system? For example, what I can do is I can do a sudo docker stop, and I can stop this container. Right, so this container is now stopped, and what I can do is I can run one more container, which would be sudo docker run hyphen it hyphen d and then Ubuntu. Sorry about that. So if I do a docker ps, I would only be able to see the container which is currently running. So you can see it is up 7 seconds ago. But if I want to see all the containers which are there on my system that could either be in the start state or the stop state, all I have to do is type in the command sudo docker ps and then -a. And with this, I can see the containers which are running. So this is container which is running, which was made around 27 seconds ago. And this is the container which has exited, which we manually stopped. And we can see that also by passing the command sudo docker ps-a. Okay. Now the next step would be to work with the container. So we have started the containers, but the next step would be to start working on them. And how can we do that? We can basically do that using the command docker exec. So what we'll do, we'll just first get the container ID. So that container ID is docker ps. All right, so this is the container ID. This is where this is the container which is currently running. Now if I want to get inside this container, the command for that would be docker sudo docker exec, so exec, then -it, make it interactive, give the container ID, and then bash would be that I want to run this container in the current terminal space that I'm working in, and the current terminal space is bash, and I'll hit enter. So let me just clear the screen. So can you see that you are now inside the container, right? So this is the container ID, and this is the user of the container. So we are basically acting as root of the container ID. That is, we are inside the container and we are acting as root. So this is basically the environment. This is the environment that I was talking about that the developer will start working in, right? And this is basically an Ubuntu container. So all the Ubuntu commands are gonna work inside this particular container. So once we are inside the container, we can do whatever like. So for example, if I have to update the container, I can do an apt-get update, and it will start updating the container as if it's a new operating system which is running on the system, right? And also to show you guys that this is different, or this is completely independent from what we were doing outside the container. You remember we have Docker installed on our host operating system. Now if I try to access Docker from here, I will not be able to do that. So if I do a sudo docker ps, you can see that it says okay, let me do a command docker ps. You can see that it says docker command not found, right? So basically Docker is not installed inside of the container, and that is the reason it is not able to access Docker. Also, an interesting thing that you can see over here is that I pass the command sudo docker ps, and it says sudo command not found. So the sudo library is not installed in the container, right? So I told you the bare minimum libraries which are required for a container to make it behave as a particular operating system is only present in the operating system, is only present in the container and nothing else. And that is why you can see even sudo as a command is not present inside the container. All right, so if you are inside the container and you want to exit the container, all you have to do is type in the command exit, and this will make you come out to your host operating system. But mind you guys, your container is still running. So if you do a docker ps, you can still see the container running in your docker ps space. Alright, so this is how you can get inside a container. All you have to do is docker exec -it and then the container ID space the terminal that you're working in, which in my case was bash. Alright, okay. Now again, so this I already showed you that if you want to stop a container, all you have to do is sudo docker stop and then the container ID, hit enter, and the container will be stopped. And then if you do a docker ps, you will not be able to see any containers which will be running inside the system. So as you can see, once we did a stop, there are no containers running over there in a docker ps space now. Okay. You can also kill a container in case a container becomes non-responsive and you're stopping the container but it's not able to exit. What you can do is you can kill a container. It's similar to that of stop, but when you stop a container, it basically gracefully exits the container. It's just like shutting down your computer or just switching off the power switch from behind the computer's power outlet. right? So if you have the stopped the container, but the container is still not stopping because of some program which is running in loop inside the container or something like that, you can immediately kill the container using the command docker kill and then the container ID. Then you have something called as docker rm. So basically I told you guys that if you do a docker ps hyphen a, you can still see the containers which were stopped, which were in the stop state, right? But as we saw in the life cycle, there's a third stage of Docker containers, which is basically the delete stage. And to reach the delete stage, you pass in the command docker rm and then the container ID. And this would basically delete the container from your system. Now let's see how we can do that. For example, if I want to remove both these containers from the system, all I have to do is take the container ID, pass in the command sudo docker rm, and then pass the container ID, hit enter, and this would remove the container from my system. So similarly, if I want to remove the second container as well, I'll just have to pass in the command sudo docker rm, the container ID, hit enter, and the containers will be removed. And now if I pass in the command, let me just quickly clear the screen. Now if I pass in the command sudo docker ps hyphen a, you can see there are no containers which now exist because we have just removed them from our system using the command docker rm. All right. Moving forward, now what to do when you have to remove an image? Now you guys know we already have an image in our Docker system, which is this. We have the Ubuntu image. Now if you want to remove this image from the system, the command for that is docker rmi and then the image ID. And this would remove the image from your system. So if I want to remove this, all I have to do is type in sudo docker rm. So rm was to remove the container. If you want to remove the image, just type in I as well in front of the rm command, and then the image ID, which is this. Pass in this, hit enter, and this would delete the image from your system. So if you do a sudo docker images now, you can see that the image is not present in the system anymore. All right, so this is how you can remove image from your system. And this was it, guys. So this was how you can basically go ahead and do these are some of the common operations that you would do in your day-to-day life while you're working on Docker. And I hope you guys are well acquainted with all these operations. So what I would suggest you guys is pause this video, try to do all those commands together, and once you're done with that, let's resume the video to going ahead, right? So our next topic is basically to create a Docker Hub account. So like I was comparing it to GitHub. So if you guys have worked on GitHub, you also have to create an account on GitHub in case you want to have your own repository where you want to push your own personal stuff or your personal code for your probably R&D or whatever you want to call it, right? Similarly, you have something in Docker Hub as well. If you have created a container for your own testing purposes or R&D purposes and you want to push it to Docker Hub so that in later time probably you can pull it whenever you want, or if you want to share that container with the other people, all you have to do is create a Docker Hub account and push your container image on that Docker Hub account. Right, so that is possible, but the first step would be to create a Docker Hub account, and for that you have these steps. So first you have to go to the website hub.docker.com. So let me quickly show you that. So all I have to do is go to the browser, go to hub.docker.com, and you would see a website which will look something like this. All right. The next thing that you would have to do is you will have to sign up on this website. So just choose a Docker ID. Now this Docker ID is basically like your username, and this username has to be unique. Right? Enter the Docker ID, enter your email address, your password, agree to the terms of conditions, and just click on sign up. After this, you would get a verification email on the email address that you specify over here. Verify your email, and that's it. Your Docker Hub account is all set up, right? I already have a Docker Hub account, so let me just quickly show you that. So my Docker Hub account looks something like this. Just give me 1 second. All right. So guys, this is my Docker Hub account. And as you can see, I have some personal containers that I uploaded over here. And I'll show you guys also how you can do this. But before that, let's come back. So once you have set up your Docker Hub account, you would be able to see your Docker Hub account, which would look something like this, right? And always remember, guys, remember your user ID because it's going to help you out in the future when you are basically pushing your custom images onto your account, that is your Docker Hub account. Alright, so always keep your user ID handy. Alright, so guys, this is how you can sign up for Docker Hub. Once you have signed up, let's go ahead and see how you can save changes to a container. Alright, so what does this basically step means? So this step basically means that if I am on my system and say, I run my Docker command. Now say I run a Docker container. Right. So this is basically download and run the container for me. So sudo docker ps. This is the container that I want to go into. Alright, so I'm now inside the container. Now what I want to do is let us do an LL, and you can see these are all the directories which are present inside the container as of now. Now what I want to do is I want to say create a directory, and say I create a directory called app, right? So if I do an ls now, you can see there is a new directory app which has been created inside this container. Right now, if I exit this container and say I do an ls, if I do a sudo docker ps, I can see that the container is running. But the catch here is that if I delete this container, say I delete this container. Okay, so one more thing, guys. If you want to remove or delete a container which is running, you can pass in the command sudo docker rm-f and then the container ID. The other way to do is to stop the container first and then delete it. That is a general way of doing it. But if you're in a hurry and you want to delete the container which is in the running state right now, just type in the command sudo docker rm-f and then the container ID, and this would remove your container. Alright, so I've deleted my container now, and if I now type in, if I again run the image, that is sudo docker run -it -d and then the image name, and if I go inside this container, and if I do an ls, you can see the directory that I created, it is not nowhere present over here now. The reason for that is whatever changes you made to the container, they were only present inside the container, and this container, when deleted, these changes do not propagate into the image that you downloaded originally. Alright. Now, if you want to make changes to a container and want those changes to be saved inside an image so that you can later on again launch a new container and it should have all those files or folders or softwares that you installed inside the container, you would have to save these changes inside the container, and for that you would have to learn how to save changes inside a container. Let's go ahead and learn how you can save these changes inside a container. Alright, so for saving changes inside a container, the command is called docker commit. Okay, so you have to pass in the command docker commit, the container ID that you want to save, and then the new image name. So basically this will create a new image of a container, and once you pass in the container ID space, you have to give the new image name that you want that custom image to have, right? So for example, in my case, if I create the folder, say app, I do an ls, I can see the app folder is there now. Right, I'll just exit the container, I'll do a sudo Docker PS. I can see this is the container ID. So I'll just copy that and sudo docker commit, pass in the container ID, and then the new image name. So the image name, let's say I say the image name is test. All right. So with this, if I now do a docker images, I can see that there is a new image which is present, which is called test. All right. And now I can run a container on the image test, and all I have to do is sudo docker run -it-d and then test. This would run the container, and if I go inside the container now, I can see that my changes would be there inside this container. So if I do an ls, I can see that the app folder is present. And this is how you can create a custom container. So I, for demo purposes, just created a folder. You can also install softwares inside a container. Like for example, you install Apache, you install MySQL, or any other kind of software that you want. Then all you have to do is save the container using the docker commit command, and you're all set. Whenever you run that image again, you would have all those softwares installed inside that container. All right, and this is how you save changes to a container. All right, so now let's do this example. So basically what we're going to do is we're going to run an Ubuntu container. We're going to install Apache on it. And once the Apache is installed, we're going to save that container into an image. All right, so let's see how we can do this. So let's clear the screen. Let's exit this container and let us first clear everything up. So sudo docker ps. So there are two containers running. Okay, so let me show you one more command, which is basically like a shortcut. So if there are like tens or five or more than five or more than three containers running on your system, you always don't have to pass in the command sudo docker rm -f and then pass the container IDs. The shortcut to remove all the containers at once is the command sudo docker rm -f and then pipe it with another command that is the sudo docker ps -a and then -q. You pass in this command, it would remove all the containers which are present in your system. So if I do a sudo docker ps now, you can see there are no containers running anymore. All right. So this is the shortcut that you can use while working with Docker. All right. So my next step is to basically install. So first I have to run an Ubuntu container. So I'll do a sudo docker -run -id Ubuntu. All right. So my container is now running. The next thing that I have to do is install Apache server on this container. Okay. Okay, so let's take it a little differently now. So basically, okay, so let it be like this. We'll come back to the part that I wanted to explain to you guys later. So basically now I'll just exec into this container. Okay, I'm in. First thing that I'll do, I'll just update the container. So apt-get update. Okay, once it's updated, the next step is to install Apache, and for that the command is apt-get install Apache 2, and this should install the Apache software. Alright, and service Apache 2 status would give us whether Apache is installed or not. So it says Apache 2 is not running, so let's start the service. So service Apache 2 start, hit enter, and if I now check the status of Apache 2, I can see that Apache 2 is running inside the container now. Awesome, this is what I wanted. So let me just exit the container now. And let me save the container. So we have installed Apache on our container. Next step is to commit these changes to the container so that it becomes an Apache container. Alright, so I'll do a sudo docker ps. This is the container ID. I'll say sudo docker commit give the container ID, and now give the image name. So let's give it as Apache. Or let me make it a little more simpler for me when I move ahead. So whenever you want an image pushed to your Docker Hub account, there is a certain nomenclature that you have to follow when you're naming your image. So first of all, you would have to write the username for your Docker Hub account. Remember, I told you to remember your user ID, and this is exactly for that. So specify your user ID slash and then whatever name you want to give to your container. So that would be Apache, right? So the naming would be specify your user ID slash your container name that you want to give. All right. So sudo docker commit container ID and then the container image name that you want to give to your custom image. Hit enter, and this should basically save your images. So if I do a sudo docker images now, you can see that our image has been saved over here with the name hshar/apache. You should also notice that now my size of the container is 212 MB. Because I've installed the software, the size has gone up. It was 86 MB before, but because we have installed a software on it, it has now become 212 MB, which is fine. Alright, so now we have the new image. So what I'm gonna do is I'm gonna remove all the containers which are running now. So sudo docker ps, this is the container running. So let me just remove it. Okay, forgot to do the -f. Awesome. So now what I'll have to do, to check whether my image is functioning properly or not, what I can do is I'll just pass in the command sudo docker run -it -d and then the image name, this is hshar/apache. Okay, I'll introduce you to one more flag, which is -p. Now what -p does is it basically does port mapping. So when I've installed Apache, if I want to check if Apache is working or not, normally Apache works on port 80, right? So on containers port 80, Apache would be running. But if I want to check the port of the container, or if I want to check if everything is running inside the container fine, I'll have to map the internal port of the container to the outside host operating system. So in this case, I'll have to map it, say if I want to map it to port 82 of my OS, of my host operating system, to the 80 port of my container, this is the command to do that. -p space port number that you want to specify, colon the port number of the container that you want to link it with. So I want to link the port 82 with the internal port 80 of my container, which has the image running hshar/apache. Alright, I'll hit enter. This would create the container, and if I do a sudo docker ps, I can see the container is now running. So let's exec into this container. So sudo docker exec -it, give the container ID bash, and if now I do a service apache 2 start, it should basically give me either an error that Apache 2 not found, or it should start the service. So let's see what happens. So it says service Apache web server Apache. So this basically means Apache was present inside this container because we did the sudo docker commit. Apache was installed inside this container, and this now service has been started. Now remember guys, we have mapped it to port 82. So now let's check if we can access the Apache software on port 82 of this server. Alright, so let me just go to the IP address of the server. So basically the server is running on AWS. So this is the IP address of the server, and I have opened it on port 82, right? So right now if I hit enter, it will not work. Reason being, I'll have to open the ports on this server. So let me just do that. Let me open all traffic so that we are on the safer side. Okay, so IP address colon port number, which is 82, hit enter. and you can see the Apache is successfully running. So mind you guys, Apache is not installed on the server. It is installed inside the container, and that software is able to access on the browser using the port that you mapped on the container. All right. So our um, for our verification, what I'll do is sudo docker ps, and I'm gonna stop this container now. Sudo docker stop, pass this ID, and now if I do a refresh over here, you can see that it says the site can't be reached. Reason being, I've stopped the container over here. All right, and this is how you can save changes to a container, install software, and create a new image out of it. Now next step would be to push it to Docker Hub, right? So I told you guys, once you are done working on your container and you've created a custom container that you want your team to access, or you want it to be there on Docker Hub for safety purposes, you can push it to Docker Hub. And to do that, the command would be sudo docker push, which I'm going to explain in a little bit. But before that, we saw the life cycle, right? We saw we can push or pull from the Docker Hub. So this is the pushing state. So we had a Ubuntu container, we installed Apache on it, and then we committed the changes, and now we have an image on our local system. The next step is to push it to Docker Hub, right? And let me show you exactly how to do that. So this is your Docker Hub, guys, and the first thing that you would have to do is you would have to log into your Docker Hub from your console, and to do that you will have to type in the command sudo docker login, pass in this command. You'd be asked the username, so pass in the username of the Docker Hub and then pass the password. So if there is any problem with your password, it will give you this error. So let me just try once more. So I'll pass in the username and then I'll pass in the password. And on a successful login, you will get this message that is login succeeded. Awesome. So I have logged into my Docker Hub. Now what I want to do, I want to push my image. So I'll have to do a sudo docker push. And what was your image name? It was hshar / Apache. This was the image name, right, that we gave to our custom container image. Hit enter and it will start pushing your image to Docker Hub. And once it has pushed the image, all you have to do is you can just visit your Docker Hub repo and you'd be able to see your image listed over here. Just do a refresh and just go to the last page, and you can see this is the image that I just pushed to the repository, which is hshar / Apache. Awesome. So we have successfully pushed our image to Docker Hub. So it's very easy. Just type in the command sudo docker push and that should be it. All right. So our next topic now is introduction to Dockerfile. And let us go ahead and learn what is Dockerfile. But before that, let us recap what we have just learned. So we understood what Docker is, why do we need Docker, what is Docker exactly. Then we went through some of the Docker operations, the day-to-day operations that you would be going through. We got acquainted through that. Then we saw how to run a container and then how to do some changes to the container and save it on your local system. And finally, how to push that container onto a Docker Hub. This is what we have learned. Now, the next step is what is a Dockerfile. So a little introduction about a Dockerfile. So you just saw that if I had to make changes to a container, I basically had to run the container first, go inside the container, install whatever software I want, install whatever I want, and then come out, commit the container, and only then it will get saved. But there's a shorter version of this when you're working on production grade environment. When you're working in a production grade environment, everything has to be lightning fast, right? And for making changes to a particular container image, you can also use something called as a Dockerfile, right? So we're going to discuss what a Docker file is now. So let's go ahead and start with this topic now. So a Dockerfile is nothing but a text document in which you write how do you want your container to be customized, right? So one example, like I just told you guys, was when I did it manually. I ran a container, I went inside it, I installed the software, came out, committed the container, and then pushed it onto Docker Hub. Now, all these changes can be automated using a script style, which we call the Dockerfile. Now, a Dockerfile is very easy to write, and there are basically some nomenclatures or there's some syntaxes that you would have to learn, but I'm sure they are very easy to learn, and once you learn them, it will only be Dockerfile that you would be using rather than doing everything manually. Alright, so let's go ahead and see how we can create a Dockerfile. So guys, these are some of the syntaxes, these are some of the important syntaxes that are relevant to creating a Dockerfile. Now, the first line of a Dockerfile is always from, right? So the image on which you want to make changes. For example, we made changes on the Ubuntu images where we installed Apache. Right, so what we did docker run -it-d and then Ubuntu. So in Dockerfile, the first base image that you want to work on, you'll have to specify it on the first line using the command from. Okay, so this area uh, of your presentation will basically tell you the Dockerfile content. So this is exactly how the content of the Dockerfile should look like. So the first command is from. So from Ubuntu. So the base image that I want to work on is Ubuntu. So this would be the first line. Second command would be to add all the files. So add is basically used to add files inside a container. Now, for example, say I create a HTML file and I want that HTML file to be added inside the Ubuntu container. So for doing that, the command add, the first argument would be the place where you want, where the files are present, and the second argument would basically be the location inside the container where you want all those files to be copied. All right, so add space dot, the meaning take files or take all the files from the current directory and put it inside /var /www and /html. All right, so this is what the add command does. The third is run. So whenever you want to run any command in the container, for example, I ran apt-get update and apt-get install Apache 2 inside the container, right? Now, if you want to run the same commands from the Dockerfile, you can do that using the command run. So over here, there are two commands that I want to run. The first is apt-get update and the second is apt-get install Apache 2, right? The -y signifies over here the option that we get, that whether you want to go ahead with the installation, yes or no. So if you specify -y implicitly in Dockerfile, it would not ask that option and it would continue the installation without any prompts. Alright, so run command is basically used to run any command inside the container on the terminal that you would have ran. Okay, then you have a command called cmd. So cmd keyword is basically used to run any command that you want to run at the start of the container. All right, and these commands run only when there is no argument specified while you're running the container. So while you're running a container, you can also specify any command that you want to run. So in case you specify a command while so for running a container, the command is docker run -it-d and then the image name. Now after the image name, you can also specify a command that you want to run inside the container. Okay, so if you don't specify anything like we did, then in the Dockerfile, this command will be running when we are starting the container. Otherwise, whatever command we specify in the docker run command, that would be running. Okay, then so this was about the cmd command line. So in this case, what we want to do is, like, remember when we started the container, we always had to go inside the container and start the Apache service manually, That is, once the image is started or once the container is started, go inside the container and type in the command service apache to start, right? So that had to be done manually. But when you pass it using the command cmd, which is nothing but all the commands run on the startup time. Whenever the container will start, this command will execute automatically if you specify it under cmd. So cmd apache ctl-d foreground would do nothing but run apache the moment the container starts, and this is exactly what we want, right? So this is possible using cmd. So again, I'll repeat it. CMD is used to run commands at the runtime of a container, and they run only when there is no argument specified in the docker run command. If there is no argument specified, the CMD command will run, otherwise it will be skipped from the Docker file. Alright, the next command is entry point. Now entry point is exactly the same as CMD, that is it runs at the starting of the container, but the only difference is CMD will not run if you specify an argument in Docker run, but entry point will run irrespective of the fact whether you have specified an argument or not. Alright, so CMD and entry point can be used interchangeably, but if there are cases when you'll be running the container with an argument, so it's better to use entry point so that the command does not get skipped. CMD command will get skipped if you specify an argument after the docker run command. Okay, so in our case, we use the Apache CTL-D foreground with the entry point command. Alright, the next command is env. So if there are any environment variables that you want to set inside a container, you can pass it using the command env space the name of the variable and space the value of the variable. Alright, so in my case, I specified a variable name which has the value Devops Intellipaat. Alright, so these are some of the commands that you can use to create a Dockerfile. Now let us create this Dockerfile on our system as well. So what I'm gonna do is I'm gonna go to my putty software and I'm gonna specify nano and then Dockerfile. So let me just create a directory first. So let me create a directory called Dockerfile itself. So mkdir Dockerfile. Let us go inside it. So cd Dockerfile, and now whenever you are creating a Dockerfile, the name of the file always has to be Dockerfile itself, right? So I'll specify nano and then Dockerfile. We went inside. So the first thing that we want to do is we want the Ubuntu image to be called. Then we want to update this image. So apt get update. Then we want to install Apache inside it. apt get -y. Sorry about that. So apt get -y install Apache 2. Alright, sounds good. Then we are going to add all the files from this directory to the directory var www.html. So we're going to create this file. Do not worry, we'll just create this file. Right, once we have done that, the next step would be to run Apache in the foreground. That is, run it. So Apache CTL -d foreground. So this would run Apache automatically. Okay, and you specify the entry point and say I also want to specify environment variable. Say let me create an environment variable called name, and I want to specify the value as Intellipaat. Okay, sounds good. So this is my Docker file, and I'll just save this now. And let me create a HTML file as well. So let's create one.html and let us make it a little simple. So this would be a hello world HTML file. Okay, the body, and in the body say I have an h1 which will say hello from Intellipaat. Close the header, close the body, and then close the HTML. Alright, this is what I want to do. I'll save this, and now we are done with the Dockerfile and we have the HTML page in place. So the next step would be to build this Dockerfile. Now let's see how we can build it. So for building this Dockerfile, all you have to do is docker build. Where do you want to build it? I want to build it from the current directory, and the image that it will create, I want to name that image as, say, new underscore Dockerfile. Okay, so it will be named like this. So I'll hit enter, and I forgot to mention sudo. So let me just clear the screen. Alright, so let me first teach you guys how to run a Docker command without sudo. So for doing that, just type in sudo usermod -a-n-g and then docker and then $user. Enter, and now all I have to do is just re-login into your session, and this should work. So if I do a docker ps now without sudo, you can see the command is running. Awesome. So what I want to do is I want to go inside the Dockerfile. Okay, and now I want to build this Dockerfile. So docker build dot hyphen t new underscore Dockerfile. So you can see the Dockerfile is now being executed, and basically this is creating the container for me, and this will basically come up with an image which will have all the changes that we just told to the container. So now if I do a docker images, I can see that there is a new image which has been created, which is new underscore Dockerfile. So let us run this new underscore Dockerfile. Docker run -it -d. Also let us specify the port number. So let us open it at port 84, and then -d new underscore Dockerfile, and then hit enter. Okay, so the container is launched now. So if I do a docker ps, I can see that a container has been launched 7 seconds ago. Awesome. And it being opened on port 84. So let's check if everything is working well for us. So we just have to change this to 84, and you can see Apache is running. Awesome, Apache is running. And now let's check our web page if it's there in the container or not. So we named it as 1.html, and yes, so this is the HTML that we created, which has been added inside the container. So let me show you inside the container what exactly happened. Okay, so docker exec -it container name and then bash, and let me just clear the screen. Okay, and let me compare it with my Dockerfile. So the first thing that we did was apt-get update apt-get -y install apache 2. This basically installed Apache, so this was clear. Then we added everything from the current directory to where www.html, right? So if we go inside where and then www and then html, and do an ls over there, you can see that the 1.html file has been added, and at the same time Dockerfile was also added. So inside the directory we had these two files, right? 1.html and Dockerfile. So both of these were added inside the container. Now to not have Dockerfile inside your container, what you can do is, instead of dot, specify dot slash and 1.html. That would solve this problem. It would only add 1.html in the container. Okay, so it added 1.html, and index.html is basically the default page of Apache that you see, right? So we added 1.html, so this was added by the Dockerfile. At the same time, what we did again was we defined Apache to run in the foreground. So as you can see, we did not invoke the Apache service by going inside the container. We just went directly to the port number that we mapped the container to, and the Apache was up and running. So that is awesome. And the last thing that we did was we defined an environment variable. So what I can do is I can echo the variable, which is $name, and you can see this is the value of the variable that is specified in the Dockerfile. I specify the variable names to be Intellipaat, and if I specify echo $name, this is the value that I get automatically. So this was set by the Dockerfile in the container image that I just created. And now what I can do is I can just exit this container, and if I want you guys to use it, all I have to do is do a Docker push to this container on my Docker hub, and you guys will also be able to access this particular container. Alright, so for that I'll just have to change the name, do a Docker push, and you should be able to use it. But I'm sure you would not be needing it, because if you pass the same commands that are written over here, you would get the exact same container that I created. Alright, so let me know if you guys face any problems in the comment section, and we'll be happy to answer all the queries for you. Alright, moving forward, now we got to know how to create Docker files. We got to know how to build images from the Docker file automatically, kind of like a script kind of thing. Alright, so now let's start with our next topic, which is introduction to a Docker volume. So what is a Docker volume? So Docker volume is basically used to persist data across the lifetime of a container. For example, I demonstrated it to you guys that when you create a container, you make some changes in the file system, you delete the container and you launch it again, and the changes are not there anymore, right? So that can be fixed. So imagine it like this. For example, you're using Apache container and you have a website inside of it, and the container stops responding because of some reasons. What you do, you delete the container and you launch it again. But with that, what happens is your website content is also deleted. And if your website content is not present in this new container, it becomes a problem. So to solve these kind of problems, we came up with Docker volumes. So what Docker volumes does is it basically maps, or it basically hosts the storage outside of the container and maps it to inside the container. That is, the storage is there on the host system rather than on the container, rather than the files being written on the container itself. They are written outside the container, and that location is basically mapped inside the container. So irrespective of the fact whether the container is deleted or started again, the container which is being attached to that volume will have the same file system as that of the older container, and that is how this problem is solved, that is of persistence of data across the container lifecycle. Alright, so there are basically two ways to do it. One is called a bind mount and one is called a Docker volume. Now, what are the differences between a bind mount and a Docker volume? Let us see that. So basically a bind mount would be that, let me just come out of the directory. A bind mount would be that I mount a particular file location inside the container. Okay, for example, I created this Dockerfile directory, right? So what I can do is I can map this Dockerfile directory inside a container. Now to mount this particular Dockerfile folder inside my container, all I have to do is docker run -it, and then there's a flag called -v that I'll have to specify. Specify the location of the directory, which is /ubuntu/ uh, home/ubuntu/dockerfile. Now this is the location of my folder, and then what is the mount point of inside my container. So say I say it's /app, right? So I'll specify that. I'll specify -d, and then I'll specify Ubuntu. I'll hit enter, and my container is now launched. Now if I go inside this container, I will be able to see that there is a folder called /app which has been created, right? So if I go to app and if I do an ls, you can see the folder, the files inside this container are that of the Docker file. Now these files are not actually copied inside the container, but these are actually being mirrored from the directory on the host operating system. That is, if I duplicate this session, let me just duplicate this session. So I'll just go inside the directory Dockerfile, right? If I do an ls and say I touch a file, say 2.html, right? So if I do a ls in the container now, I can see that there is one more file 2.html, right? So it is inside the container. So whatever changes I make inside this directory will automatically or dynamically be available inside this container. Okay, the reason for that is that this directory is mapped to the directory /app in the container. All right, so this is called bind mount, but there's a disadvantage with this. The disadvantage is that a bind mount will only work when the file system is the same that you have specified, like over here in this container, right? For example, what can happen is I can specify this bind mount to be in the configuration of the container, and I can push it to Docker Hub. So anyone who is downloading this container will automatically have this bind mount on his operating system. But the problem which will arise is that, say you download this container on a Windows operating system, right? In the Windows operating system, this file path that I gave /home/ubuntu/dockerfile is not going to exist, and that is where it is going to give you an error, and it will cause you a problem, right? So this way of persisting data is a little difficult, or is a little I'd say complex when it comes to different environment setups, when you're dealing with different environments. For example, if I have to talk about, say, a different operating system, say I want to work in CentOS, so in that the file structure would be a little different, right? For any other operating system it will be a little different. For Windows it is completely different, right? So a bind mount will not work in different environments, and that is where it has a disadvantage. But then this advantage is basically overcome by volumes. Now what are volumes? Volumes are basically entities, or are basically storage which is managed by Docker. Bind mounts are not managed by Docker, because you create the directory, you decide which directory your data is going to reside in, right? And inside that directory you are making the changes, and that is being reflected in the container. But if you create a volume, the Docker engine which has been installed on the host operating system automatically identifies where this volume has to exist, okay, and then creates that volume over there. Also, in bind mount it is a little difficult to basically migrate the data. In volumes it is very easy. You just take the volume up, and then just put it on some other system and it will work. But in case of bind mounts, you will have to decide at which place you want to keep it, and then bind that place to the container. Only in that case it will work, right? Let me show you what happens in case of a volume, right? So in case of a volume, if you want to create a volume, this is the syntax. So the syntax is docker volume create and then name of the volume. So let me show you how you can create it. So let me just docker volume create, and let us create a volume, say test. Okay, so this would create a volume called test, as you can see over there. Ignore the warning, guys. So this created a volume test, and if you want to see all the volumes which are present on your system, you can pass the command docker volume ls, and this would give you all the volumes which are present on your system. So on my system right now, only the test volume is present. I don't want to have to know where is it present, because Docker manages the handling part of the file system itself. I don't have to worry about that. I just want to know that if there is a volume. So yes, there's a volume on my system which is called test. Awesome. Alright, so the next thing that I have to do is basically I'll have to type this command docker run -it -mount. And so basically, if I were to give you the syntax, this is the syntax for mounting a volume. So docker run -it -mount source would be equal to the name of the volume. So in our case, the name of the volume is test. Then the target would be where do you want to mount it inside the container. So we want to mount it inside /app, right? And then -d and then the image name. Alright, so once the container is launched, now what we can do is we can go inside this container to check if everything is working fine. And we'll go inside app and do an ls. So there's nothing inside this volume as of now, right? So what we can do, we can create, say, touch, then 1.html, and then touch 2.html. We can do all this, and then what we can do, we can also duplicate the session. Let me just duplicate the session. And what I'm going to do now is I'm going to launch one more container. Okay, so I'm going to launch docker run -it -mount, and then say source is equal to test, and target could be some other folder as well, but for the sake of simplicity, let's keep /app, and then -d and ubuntu. This would launch one more container, right? Let's go inside this container, docker exec -it, this, and then bash. Okay, let's go inside app. If I do an ls, you can see that whatever changes I'm making in this volume is also being reflected in this container. So say I create 3.html over here. If I go here and do an ls, I can see the 3.html as well. Alright, so this volume is basically being shared between two containers. Even a bind mount can be shared between two or more containers. A volume can be shared between two or more containers. But in case of volume, you do not have to worry where your volume is being stored. It is automatically handled by the Docker engine. Okay. The other cool thing over here is that if you delete this container and launch it again, it'll all be the container, or your end user will not even realize if anything changed. For that, let me give you an example. So let me just exit this container, and we created a image called new_Dockerfile. Okay, so what I'm gonna do is I'm gonna launch docker run -it, and then source is equal to let me create one more volume, docker volume create, and let us create a volume for Apache. Okay, now what I'm going to do is I'm going to launch docker run -it, and then -mount. Source would be Apache. Now look at this closely, you will get the difference. So source is Apache, and what I want to do is I want to target this particular directory var www and then html. So whatever would be inside this directory will automatically come inside the volume. Okay, so I don't have to add anything into the volume, and I'll show you how to do that. So you specify this -d new_Dockerfile, Dockerfile. This was our image name, and let us hit enter. So it created the container. Let's go inside this docker exec -it and then this container and then bash. Okay, so we are inside the container now. Now, if I go to cd var www html and do an ls, you can see the files are still here, but these files are also now mounted on the volume, and that is evident over here. So if I exit this container and if I launch a new container with the mount as Apache and target would be say /app and the image is this. Okay, so this is the Ubuntu image, right? So it should not have the files inside it, but if I go inside this container now, can you see the files over here are same as what was there inside this container var/www/html. Okay, now the beauty is this, guys, that if I come out, say I create a 2.html over here, right? So what I do is I come out of this directory, okay, and what I do is I create nano do.html. I create a file and then I specify that HTML body h1. This is the new HTML file. Close the header, close the body, close the HTML, come out. Okay. Now I want to copy this tool.html inside this container. So what I will do, I'll do a docker cp ./2.html and then /var/www/html and then the container ID. /var/www/html. Okay, so now 2.html is present inside the container. Okay, now what I will do, I'll just delete the container. I'll delete the new underscore docker file container, docker rm-f, delete. Okay, so ideally if I now launch a new docker run -it -mount source is equal to Apache, target is equal to /var/www/html. Okay, and hyphen p also we specify that we want 81 port to be exposed, and hyphen d and then the image name new underscore Dockerfile. So what will happen now is this, that if I go on the browser, if I go to port 81, the container is running. If I go to 2.html, you can see that the new file is also there in this container, that is new underscore docker file. So it does not matter if your container has the file or not. If you have mounted the volume and that volume at some point had that file inside it will have it inside this container as well. Okay, originally inside this image you don't have the 2.html, right? And let me prove that to you as well. So if I do not mount the volume and I launch this container, right? So if I go to this IP address, and but on page 82 you can see the container is up and running. If I go to 2.html, it will say 2.html was not found on this server. Reason being, the volume is not attached to this server. This file only has 1.html that we wrote using the Dockerfile, right? For volume, we have it in attached in the container which is mapped to port 81, and that has the file 2.html, which is this. So awesome, guys, we have successfully understood what Docker volumes are, and I'm sure that you guys have also understood. If there are any doubts, guys, you can mention it in the comment box and we'll be more than happy to help you out with your doubt. Alright, so with that, guys, now we come to the next topic of our session, which is how are microservices relevant, right? So till now we have seen how we can deploy a single container and do things with it. But usually in a production grade environment, we have multiple Docker containers which are working with each other. Now, why do we have that? Let us understand that using this topic. So first, let's understand what is a monolithic application. So guys, a monolithic application is an application which has everything inside one particular program, right? For example, let us take the scenario of an Uber app. So our Uber app has things like notification, we have things like mail, payments, location services, customer service, and passenger management. This is there inside one app, right? You can see all of these things inside one app. So if you can see it inside one app, that does not necessarily mean that it is actually one program of Uber that they have written, right? But for now, let's consider everything is under one program. When I say one program, probably you have written a Java file, or you have written a C file, and everything is there in that C file, or everything is there in the project in different files. Basically, everything is there on one server, is what I mean. Right? So if that is the scenario, what will happen, that if I want to change code in notifications, I will have to pull the whole code base. I will have to go to the notifications file, and I have to change the code over there, and then I have to push the whole code again back to GitHub, which will basically get deployed on production after being tested and everything, right? But the problem over here is that if there is any problem in the notifications code that I just changed, it will have a repercussion on all the components of my app, right? There could be that I did a mistake and probably there is something wrong with the mail program now. Although my intention was not to touch the mail program, but because I had to work with the code base which had everything, probably something went wrong over here, or something went wrong over here, or something went wrong over here. So this was a problem with a monolithic application. That is, that you had to submit the whole code base, even if you had to change the minimist thing that is there in the code, right? And this also led to downtime, because when you are changing the code base, there will be a certain amount of downtime that will occur. And there is also a lot of risk, because like I said, the other files of the same project could be impacted. For example, in our case, I said that if notifications, or say if location services is not working, probably it will have an effect on payments, or it will have an effect on mail if the code is related to each other, or if a function is being called from each other, etc., etc. That is how a normal a program is. In one file you define a function, in the second file you're basically calling that function. That happens, right? So all of these are dependent on each other, and whenever the components, whenever the module, so all of these small things like notifications, mail, payments, passenger management, customers, or these are all small modules of a program. If these modules are interdependent to each other, it will be called a monolithic application, right? But when we talk about the disadvantages of a monolithic application, they are the following. So like I said, if the application is large and complex, it will be very difficult to understand. So if your Uber app is now having more and more features, and if someone has to add a new feature, he first has to understand all the dependencies between the components, right? He has to understand the whole code base, and then only he can add a feature as to understanding what will be the repercussions, or what all files he or her has to handle if he's going to put a code inside the code base, right? So it is a little difficult to understand. Second thing is the whole application is redeployed. So like I said, the whole code is again deployed, and then there will be a certain amount of downtime which will be pertained to you updating the application, right? The third thing is, if there is bug in any of the module, and because in a monolithic application everything is dependent on each other, it can lead to an entire downtime of your whole application, right? It can bring down your entire application just because of a bug in a single module. So this is also a problem in monolithic application because the components are dependent on each other. And the last one being, it has a barrier to adopting new technologies. And this basically means, say your notification code is in Java, and your and your passenger data program, because it's a monolithic application, also has to be in Java. All of your modules that you're defining, all of the features that you have defined, have to be in one particular language. That is what a monolithic application means, right? So there was a restriction to adopting new technologies as well. So it could not be like one module of mine is written in some other language, the other module is written in some other language. This was what a monolithic application was. Now, to solve this, we came up with the microservices architecture. Now, what is the microservices architecture? Each and every module, that is a customer services function, or the notifications function, or the mail function, the payments function, passenger management function, location services function, they're all segregated from each other. They all exist independently. That is, they're not dependent on each other. So if they have to interact, obviously they'll have to interact with each other. For example, in Uber, until and unless you don't make the payment, you will not be allowed to book a cab, right? So still communication has to be there between these two components. That is, the payment and the booking has to be communicating with each other. But now they don't have to communicate through in between the program. They can communicate through uh, probably HTTP ways, or by hitting the API of each other. They can do that by probably sending JSON to each other and stuff like that. So they can communicate in that way. They don't have to communicate from within the program. And that is the beauty of microservices, that the services that we are defining now are not dependent on each other. For example, say if the notifications is not working, the notifications module is not working, then in that case, it's not like your Uber app will go down. Probably in that case, it will say we our notifications is having some problems, but you can still book a cab. You'll still be able to book a cab because booking of cab is nowhere related to notifications. But if we compare it to a monolithic application, in that case, because the code was dependent, and if there was something wrong in the notifications app, the whole application could come down, right? Because the code was not isolated to their member functions or to the member modules. But now, because each and every function of the application can exist on a different server altogether, the downtime of the application becomes almost zero when we have to update a feature. For example, if a developer has to update a feature in, say, the payments app, for example, he has to add a new payment method, he will only download the code base for the payments app, make the changes over there, update the code on the payments module, and if there are any problems, there will be problems only to the payments module. The other services will not be affected. Okay, and this is what microservices are. Now, you might be wondering that this is a Docker session. Why and how are these microservices related to Docker? So to answer that question, these applications, all these microservices are deployed on Docker containers. Okay, so all these act as separate entities, and these containers then interact with each other. And now this also solves the problem of barrier of adopting of new technologies. Reason being, your containers could be of different technologies. For example, your customer service could be written in Python, your notifications could be written in Java. But if your customer service and notifications programs have to interact with each other, they can interact through JSON. JSON is a way of writing a file, just like we have CSVs wherein values are separated by commas. In JSON you have a structure, right? any kind of program, be it any language, can convert a file into JSON, probably using libraries or having inbuilt functions for that, right? And then pass it on to the other service which has to read the information. So with microservices, our problem of barrier restriction, of technology restriction was also solved. So the advantages would be, because the application is distributed, can be understood really well. It is not like if a developer has to work on a particular feature, he has to understand all the features of the application. He should know which application should he, or which modules of the program should that particular program that he is developing communicate to, and that all he has to know. And of course the code of his own function as well, right? And of course, if he makes any changes, and if he makes any bugs also in the program, it will not affect the whole application. It will probably affect only that function which he is creating. Okay, I guess we have covered all the advantages. So the first one being easy to understand, then the code which has to change will only be changed for the microservice which has to be worked on. Then the bug in one service will not get into all the components of the application. It will only be isolated to that particular function. And of course, you can use any technology that you want with the microservice that you are working with. Okay, and all of this is possible using containerization. Okay, now because we were talking about deploying multiple containers, we have to talk about how to deploy them using Docker Compose. Now, if we want to deploy multiple containers, till what we have learned so far, the only way to do this is by either using Docker Run, or probably creating a script file which will build multiple Docker files and then hence build those images. But there is even a shorter way to basically build images and run them, and that is possible using Docker Compose. Now, what is Docker Compose? Docker Compose is basically a tool which can be used with Docker to create multiple containers at once, create and configure multiple creators at once with a single command, right? And the way you can do that is by writing a YAML file, right? So you write a YAML file with all the configuration required for the containers. And of course, I'm talking about containers, that is more than one containers. You can have 100 containers also that you can launch with one single command using the Docker Compose file. Okay, and this Docker Compose file is written using a YAML format. Now we are working with us. Now, if I want to demonstrate the power of Docker Compose to you, I can do that using a sample Docker file that I have created. So this sample Docker file, what will it do? It will basically deploy a WordPress website. Now a WordPress website has a lot of dependencies, guys. It has to has MySQL in the backend. It has to have the WordPress container in the front end. And of course, you'll have to configure the DB password and everything inside the container as well, right? Now, one way of doing it is doing manually, that installing WordPress and then configuring the variables inside it, and then doing the same with MySQL. But there's a shorter way to do that, and that way is using Docker Compose. Now, this Docker Compose file has actually been written in YAML file. So if I were to take you through it, the version of the Docker Compose file is version 3.3. And there are basically two kinds of containers that we are launching. The first kind of container is the DB container, and the second type of container is the WordPress container. Okay, so the first we launched DB container, and the image that we are trying to pull for the DB container is MySQL 5.7. Okay, in the MySQL 5.7 container, we are defining a volume which is DB underscore data, and this is the target of the inside the container where it should be mounted. That is var live MySQL. Okay, so the environment variables for this container are MySQL root password, that is MySQL data, MySQL user, MySQL password. These are the values to these environment variables that we are also configuring inside the Docker Compose file itself, right? So inside this container, these are the environment values which will be configured. And then, so this is the end of it. This is what we have done in the DB container. Now we are talking about the WordPress container, in which we specify that it depends on DB, which this will basically create a link between the WordPress container and the MySQL container or the DB container, right? And with this, the WordPress container will be able to communicate with the DB container. Then we specified the image of the container that we want to download. So it's WordPress and that to the latest version. The ports that we want to expose. So inside the container, the WordPress is available on port 80 and we are mapping it on the host with port 8000. Okay, and then the environment variables we specify that the WordPress DB host is DB colon 3306. So DB is basically the host name for this service that just got created, which has MySQL inside of it, and MySQL is always available on 3306 port number. So that we specify over here. Then we have the WordPress DB user. So we specified the DB user, that is the MySQL database user, as WordPress. So that is exactly the same value that we're specifying over here. And the DB password is again WordPress, and that is also that we specified over here. Okay. And what else? So this is it. And after that, we specify that the volume which has to be created is DB data. So this is for the whole YAML file. That there's a volume which is being created, which is called DB data. Now this is a YAML file which will create two containers, which will configure it, and then this will happen in like 3 seconds, right? So let us go ahead and try this sample Docker file out. But before that, Docker Compose, guys, actually has to be installed on the system, irrespective of the fact whether you have installed Docker or not, right? So Docker, when you install, it does not install Docker Compose automatically, except the users who have installed it on Windows and Mac using Docker Toolbox. If you installed using Docker Toolbox, it has everything installed. But if you have installed it on Linux and you have just installed docker.io, it will just install the community edition version and the Docker Swarm. Docker Compose is not installed by default. Now to install Docker Compose, all you have to do is, let me first demonstrate it to you that Docker Compose is not present. So Docker Compose hyphen version. So you can see it is not there as of now. So what I can do, I can go to my browser. I will search for install Docker Compose, and the first link is basically the official link. Alright, so for installing it on Linux, just click on Linux, and these are the commands for installing Compose. So first we'll copy this command, that is, we'll have to curl the file. So the file has been curled now, and then we'll have to change the permissions for it, for the file which has just been downloaded, to be converted into an executable file, and that's it. And now if I run Docker Compose version, I can see that the Docker Compose version is 1.23.1 and the build is this. So Docker Compose has been installed automatically. Now the next step is to basically create a YAML file. So for that, let us create a YAML file for, so let me first create a directory. So it would be compose. Let's get inside compose, and now let's create a YAML file for WordPress dot YAML. Okay, and if you basically, this WordPress compose file is available on Docker Docs, so you can directly go here and you can try this YAML file on your own as well. Just copy this YAML file, paste it into your YAML file that you are creating, and then save it. Just let's verify if everything has copied correctly. So yes, it has. And now finally save this YAML file and then pass the command. Okay, so there's one more thing that I want you to know, but that will be evident from the error, which is that the Docker Compose file has to be named a proper, has to have a proper name. For example, if I pass the command Docker Compose For basically running your Docker Compose YAML file, the command is Docker Compose up and then -d. You pass it, and then it'll give you an error, can't find a suitable configuration file in this directory, right? So it says that file can only be of this name, dockercompose.yaml or dockercompose.yaml, right? So what we're going to do, we'll just name it the same. So I'll just rename the file to be dockercompose.yaml. Okay, so the file has now been renamed, and now let's pass the command docker compose up -d. I'll hit enter, and as you can see, everything has started automatically, and it is pulling the containers as of now. Once it has pulled the containers, it will start configuring the container. So db container has been completed. Now it is downloading the WordPress container, and then it will configure it. And once the configuration has been done, yes, so it's done. So our WordPress website is now up, and all we have to do is go to the EC2 dashboard, go to the running instances. So these are the instances that we launched. This is my instance. I'll just copy the IP address, and WordPress would be available on port 8000. Hit enter, and here you go. So website is up and running, and if I go on continue, I just have to specify the value. So let's keep the site title as Intellipaat, username as Intellipaat as well, password would be Intel123, and then your email, so it would let it be something random, intellipaat@intellipaat.com, and we'll click on install WordPress, login, and then username or password. So let us specify it as the same that we gave, right? And now if it logs in, that basically means that it is being able to communicate with the database as well, right? So your WordPress website is all up and running. It is now configured with your MySQL database, and that is how it is interacting. And this is your dashboard. This is basically from your WordPress container. Your data is all being stored on the MySQL container, and this is a classic case of a multi-tier app that you have just launched on Docker Compose. So if I do a Docker PS, you can easily see that this is the WordPress container which is running, right? And it is being exposed on port 8000. And then you have this MySQL container which is running, which is being exposed on port 3306, on which this WordPress container is being able to interact. Alright, so guys, this was how you can launch multiple containers at once using Docker Compose, and this is also kind of like a microservice, although this can be further be broken down, but those broken down services can also be launched through Docker Compose, and everything can be configured in the Docker Compose YAML file itself. Alright, but again, microservices are actually not launched through Docker Compose. They are basically put on something called as a container orchestration tool. So what is exactly a container orchestration tool? Right? So a container orchestration tool is when you have multiple containers that you have launched and you want to monitor their health as well. For example, if I come back to this example that we just did, what I'll do, I'll just docker rm -f, and I'll specify the container ID. I'll hit enter. The container is removed, right? And now when I go over here and if I hit enter, it'll say the site can't be reached. If I hit enter again, it'll again say the same thing because your site is gone. You accidentally removed your container, or your container stopped working because of some reason, and now you're not able to access your container. Your website is down, it's gone. This was a problem which was there with traditional methods of using containers or microservices on Docker. But then there was something called as container orchestration, which became very popular, which basically says that all your containers health will be monitored by Docker itself. So if there is a container which goes down, if there is a container which is not healthy anymore, what Docker Swarm does is it automatically repairs it by stopping the container and launching a new one in place of it, and the end user will not even realize what happened. All right, so this automation led to what we today known as container orchestration. Now container, there are a lot of container orchestration tools. With Docker, pre-packaged comes Docker Swarm. So we're going to discuss Docker Swarm now. So what is Docker Swarm? So it's basically a clustering and scheduling tool which is used for container orchestration of Docker containers. And with Docker Swarm, you get the functionality of automatically monitoring the health of containers, and it helps you keep a healthy number of containers that you have specified always in the running state. That is the basic aim of having a Docker Swarm up and running. Now, how does a Docker Swarm basically work? So a Docker Swarm basically works like this. So a Docker Swarm cannot work with just one machine. All right. So because like containers, even machines can be faulty sometimes. Maybe you have configured Docker Swarm on a single machine, which can automatically repair containers. But what happens if the machine goes down? Right? So to mitigate those kind of things as well, we came up with distributed kind of an architecture wherein you have multiple machines running in the swarm. So there in the swarm there will be one machine which will be called as the leader, which will basically tell the workers what to do, and the workers will have the containers running on them, right? So you have the leader like we have it over here, and then you have multiple workers which are running on the cluster, and these workers will run the containers that we want to launch. So this was about Docker Swarm, but this is not it. Let's go ahead and start a container, or let us go ahead and start a cluster using Docker Swarm. So let us see how we can do that. So for that, let's go ahead and first launch a machine on AWS. So we have the master. Let us launch a worker. So for that, let us launch an Ubuntu system. Okay, so now our Ubuntu system is now launching. Let's name this instance as a worker. Okay, so while this is launching, you'll have to do some steps on your leader. So say this is the instance that I want to become the leader for my Docker Swarm cluster. So what I'll have to do, I'll have to say Docker Swarm init, and then I'll have to specify the advertise address. So advertise address is basically the private IP address of the instance. So in my case, the instance is, this is the private IP of my instance, right? So I'll have to specify this over here, and then I'll hit enter. So with this, you will get this command: swarm is initialized, current node is this, and it is now a manager. So manager is nothing but a leader. Okay, and for any node which has to join to this manager, they'll have to pass this command, that is docker swarm join, and then this command that they'll have to pass. So for this, so basically I'll have to log into this particular worker of mine to install Docker first, and then we'll go ahead and join it to the cluster. So let us connect to our worker, and let me make the font a little bigger so that you can also see what I'm typing. Okay, great. So this is my instance. Now what I'll have to do, I'll have to first install Docker. So let me do an update first. So Docker is updated. Now let me, the machine is updated. Now let me install Docker. So sudo apt get install docker.io. Alright, so Docker is installed. Let us verify that by typing sudo docker version. Great, so Docker is installed. Now Swarm is automatically installed when you install Docker. So all you have to do now is go here, copy this command and paste it over here, right? And also while we are doing that, I'll have to open the ports for uh, these instances to interact with each other. So let me put all traffic over here, and now my instances should be able to interact. So I'll just pass the command here and hit enter. Alright, so I've figured out what the problem was. The problem was I've not specified the address correctly. So my master is basically on this IP address. So let me copy that and let me pass the command again. Now this is the command that we get. Let us copy this. Let us paste it over here. Hit enter. And you can see it says this node joined as a swarm worker. Alright, awesome. Now if I go here and I do a docker node ls, you can see that there I have two nodes which are there. This is my current node, which is the leader, and it's in the ready state, and so is the second node, which is also in the ready state and is joined the swarm. So this is how you can create a Docker Swarm cluster, guys. So again, to be very clear, the first thing that you'll have to do is do a Docker Swarm init on the master node. Then you'll get a command. Just pass that command on the worker, and your worker will directly connect to your master. Now, if you want to leave the cluster, all you have to do is say sudo docker swarm leave, and you can see it will say node left the swarm. And if you do a docker node ls on the master, it will, in a few moments, when the health checkup has failed, it will say the status is down for this particular node. Okay, if you want even the master to leave the swarm, all you have to do is pass the command docker swarm leave on the master as well. Now as you can see over here, this node, because it has left, the status is now down, which basically means that the node is no longer reachable. Okay, now if you want the master to also leave the swarm cluster, all you have to do is say docker swarm leave and then say hyphen force, keep enter, and it'll say node left the swarm, and your swarm cluster has now been left. Okay, so this is how you can go ahead and create a docker swarm cluster. And the command, like I said, is docker swarm init advertise address equal to IP address of leader. Specify that, hit enter, and just copy this command on the worker, and it will work like a charm. Alright, so our next step is now to deploy an app on the Docker Swarm. So before that, let me quickly launch the Swarm cluster again. Docker Swarm init advertise address and specify the IP address of the master, which is this. So this is the IP address. Just specify that, hit enter, and then copy this command and pass it on the worker. Okay, and if I do a docker node ls over here, you can see the cluster is ready. Awesome. Now what I want to do, I want to deploy an app on Docker Swarm, but before that we'll have to understand how does an application actually work on Docker Swarm. So an application works something like this. So basically you create services on Docker Swarm, and that service will basically create containers for you for that particular image that you have specified, right? So all right, so let's go ahead and create a service. So guys, this is the syntax for creating a service in Docker Swarm. What we'll have to do is we'll have to type in docker service create and then specify the name of the service. Say I want the name of the service to be Apache, and then specify the number of replicas that we want to run. So say I want to run 5 replicas, and then the port mapping. So basically I want it to be launched on port 83, right? And then the name of the image. So say I'm launching it on hshar/web app. Okay, I hit enter. It'll run 5 containers. It'll verify if everything is running fine, and once everything is running great, it'll exit. So now if you want to see what all services are running on your Swarm cluster, all you have to do is say docker swarm service ls, docker service ls, and it will show you that this is the service which is running. It is running in the mode replicated, right? And it has 5 to 5 replicas running, and this is the image name. Now I'll show you a very awesome thing. So basically this port is 83 is exposed, right? So what I'll do, I'll go to the master's IP address, which is this. I'll go here, I'll type this, I'll go to port 83. Alright, this is working. Now what I'll do, I will go here, I will go to the worker, I will again go to the worker's IP address, and I will go to port 83. Awesome, isn't it? So basically in Swarm, any IP address, either of the master or of the worker that you go on, they will have the application ready on both the servers on port 83. And the most awesome thing is that I showed you guys that if I do a docker ps over here, I can see that there are out of 5 containers, there are 2 containers which are running on the leader, and there should be 2 containers running over here on the worker. So there are 3 containers running over here. So what I can do is I will basically just do a sudo docker rm-f, and what I'll do, I'll remove all the containers. Removed. And if I go to my master's IP address again and hit enter, I still have the containers running over here, right? Similarly, if I go here sudo docker rm-f, and then I say I want to remove everything. I forgot the sudo over here. It removed 3 containers, but if I go to my web browser and refresh the worker's IP address, I still have the container running over here, right? This basically means that my containers are being auto scaled, which means if they get deleted, it again gets created. So you can see I deleted the containers over here, but if I do a docker ps again, can you see it has 3 containers now launched? And I guess if you go on the worker and do a ps over here, now it should have 2 containers, exactly as we saw, right? So it automatically creates the containers again, and it will always maintain the number of replicas to be 5, because that is what you have specified, right? That is what it will always retain. Now you can always scale the replicas, and for that all you have to do is docker service scale Apache, and then just specify the number of replicas that you want. Say I want only 2 replicas to be there. I'll hit enter, and then what it'll do, it will basically scale down to only 2 replicas. Now if I do a service ps, docker service ls, you can see there are only 2 replicas running now. So if I do a docker ps here, I have 1 container over here, and if I do a docker ps here, I have 1 container running over here. Alright, so you can also scale up and scale. I can also scale up, right? So I can again just go over here and type in the command 10. It'll start 10 containers for that web app, right? And you can verify that. You can verify if I do a sudo docker ps over here, it has around 5 containers here, and if I do a docker ps here, it has around 5 containers here. If you want to remove a service, if you want to remove an application from the cluster, all you have to do is docker service rm and then specify the name of the service, and it will remove that service. And now if I do a docker ps, it should slowly remove everything out of here. So it's docker ps again. Slowly it will remove everything from the containers. So see, the containers are gone over here, and similarly if I see here, the containers are also gone over here as well. Okay, and again, like I told you guys, if you want to leave the node, all you have to say is do sudo docker swarm leave. This node has left the swarm, it will say. And similarly, if I want to leave the master as well, all I have to say is docker swarm leave, and on the master you'll always have to force, and it'll leave the swarm as well, and then you'll have a clean machine again. All right, so this is how you can deploy an application on Docker Swarm. All right, so our next topic is deploying a multi-tier app on Docker Swarm, and we would be doing this in our next session or in our further sessions on Docker Swarm exclusively. Now because this topic involves the know-how of how networking works in Docker Swarm, so I'll be explaining in detail in our next video, which is going to be there first, so stay tuned. So summarizing what all did we learn today. So we got introduced to Docker, we saw how we can some common Docker operations, then we saw how we can create and save a container, push it to Docker Hub, how to create containers using Dockerfile. Then we saw how to create multiple containers using Docker Compose. We learned about microservices. We saw how to orchestrate containers using Docker Swarm, how to deploy a multi-cluster application. And then we also saw how to delete a swarm cluster once we are done with it. All right, so this was the summary of our today's session. And this topic of deploying a multi-tier app, that is two containers which can interact with each other irrespective of the fact where they are on the cluster, is something that we are going to do in our next session. All right, so thank you guys for attending today's session. I hope you guys learned something new today. So as always, if you like this video, please click on the like button and subscribe to our channel for any future updates. And if you have any doubts regarding any of the topics that we discussed today, I would request you all to comment it in the comment section that is mentioned below, and we'll be happy to answer it for you. All right, so with that guys, I'll take a leave from you guys. Have a great day ahead, and goodbye.